Welcome everybody. We're going to find dy over dx in case of the implicit function defined by equation tangent of x minus y equals xy over 1 plus x squared. And we start by applying derivative to both sides of the equation, derivative with respect to x. And we see that we're going to have to do derivative of tangent on the left and derivative of this fraction on the right. So breaking it up into smaller pieces, derivative of tangent of x minus y is going to be, according to chain rule, we have derivative of tangent of u. So we're going to have secant squared of u times derivative with respect to x of whatever was inside of tangent. And continuing on, this boils down to secant squared of x minus y times derivative of x minus derivative of y. And derivative of x is 1, derivative of y is dy over dx. And then it's actually beneficial to distribute secant squared x minus y over those two terms, so that we get secant squared of x minus y minus secant squared of x minus y times dy over dx. So that's as far as we're going to go with derivative of tangent of x minus y. Then with the derivative of xy over 1 plus x squared, we're going to use quotient rule, since this is a fraction. So this is derivative with respect to x of x times y. That's the numerator, times 1 plus x squared, minus xy times derivative with respect to x of 1 plus x squared. All of that over 1 plus x squared, the entire expression squared. So that's the quotient rule. Now, with the derivative of x times y, we have to follow the product rule. So we're going to have derivative of x times y plus x times derivative of y. All of that multiplied by 1 plus x squared. And then we have minus xy multiplied by 2x, since derivative of 1 plus x squared with respect to x is just 2x. And we have 1 plus x squared, quantity squared, in denominator. So moving on, we see that derivative of x with respect to x is 1. Derivative of y with respect to x is dy dx. So this is what we get. And then again, it's beneficial to distribute 1 plus x squared over those two terms. And we arrive at expression y times 1 plus x squared plus x times 1 plus x squared times dy dx minus 2x squared y. All of that over 1 plus x squared quantity squared. So we haven't done those two computations, so we can come back. And so for the derivative of tangent of x minus y, we got all of these. So that's a copy of that result. It should be equal to whatever we get out of derivative of xy over 1 plus x squared. And we got this lone fraction. So then, to simplify the situation, we're going to multiply both sides by this denominator. So effectively, we're going to have on the left each of those two terms getting an extra factor of 1 plus x squared squared. On the right, we're going to have the entire numerator by itself. Okay, so once we have that, we're going to collect the dy over dx terms on the left-hand side. So we're going to effectively subtract this piece from both sides. And then we're going to move this term to the right-hand side by, again, subtracting it from both sides. So we're looking at negative 1 plus x squared, quantity squared, times secant squared of x minus y times dy over dx, minus x times 1 plus x squared times dy over dx equals y times 1 plus x squared, minus 2x squared y minus 1 plus x squared squared secant squared of x minus y. On the next step, we're going to factor out dy over dx on the left-hand side. So we have dy over dx times this long parenthesis equals that same right-hand side. And to get dy over dx, we just divide both sides by this long parenthesis. So we end up having this long expression over that another long expression. And that's our dy over dx. So dy over dx is equal to a fraction with the numerator being y times 1 plus x squared minus 2x squared y minus 1 plus x squared quantity squared multiplied by secant squared of x minus y. And the denominator of that fraction is negative 1 plus x squared squared times secant squared of x minus y minus x multiplied by 1 plus x squared. We're going to find dy over dx in the case of implicit function y defined by equation sin x plus cosine y equals sin x times cosine y. So as usual, we're going to apply derivative to both sides. So doing derivative of sin x plus cosine y, it should be equal to derivative of sin x times cosine y. On the left-hand side, we have sum of two terms, so we have derivative of sin x plus derivative of cosine y equals derivative of sin x times cosine y. So breaking it up into small portions, we have the derivative of sin x is equal to cosine x, then derivative of cosine y is, by the chain rule, negative sin y times dy over dx. And then derivative of sin x times cosine y, by the product rule, is derivative of sin x times cosine y plus sin x times derivative of cosine y. And this ends up being cosine x times cosine y plus sin x multiplied by negative sin y times dy dx. So distributing, well, multiplying out and simplifying, we get that this ends up being cosine x times cosine y minus sin x times sin y times dy over dx. So now we can go back to the original problem. So for the derivative of sin x, we got cosine x. For the derivative of cosine y, we got negative sin y dy over dx. And for the derivative of right-hand side, we got cosine x cosine y minus sin x sin y times dy over dx. So we're going to collect dy over dx terms on the left-hand side. So we're going to move this sin x sin y dy dx term to the left, and we're going to subtract cosine x from both sides. So this way we have negative sin y dy dx plus sin x sin y times dy dx. All of that equals cosine x cosine y minus cosine x. Then we can factor out dy over dx. So looking at negative sin y plus sin x sin y multiplied by dy dx. All of that equals cosine x cosine y minus cosine x. And if we divide both sides by what we have next to dy over dx, we're going to get dy over dx by itself. So this is dy over dx equals cosine x cosine y minus cosine x, all of that divided by negative sin y plus sin x sin y.